Assalamu alaikum and hi everyone. In this video, we will show you how to conduct standard Proctor compaction test for soil. This laboratory test is performed to determine the relationship between the moisture content and the dry density of a soil for a specified compaction effort. The amount of compaction is quantified in terms of the dry unit weight of the soil. Usually, dry soils can be compacted best, and thus a greater unit weight achieved, if for each soil, a certain amount of water is added. In effect, water acts as a lubricant, allowing soil particles to be packed together better. However, if too much water is added, a lower unit weight will result. Thus, for a given compaction effort, there is a particular moisture content at which dry weight is greater and compaction is best. This moisture content is known as the optimum moisture content, and the associated dry unit weight is called the maximum dry unit weight.
Here are the equipment used in this test. Cylindrical metal mold. Measuring cylinder, jacking apparatus for extracting. Balance. Large metal tray. Metal rammer with 50 mm diameter, cylindrical metal mold. Scoop. BS sieve number 4.75 mm size passing and receiver. And spatula.
Firstly, we need to sieve the soil sample using the sieve size 4.75 mm passing. Prepare a representative batch of the soil to be tested by breaking down soil clumps into individual particles. Then, pour the soil sample into the large tray, add water and mixing thoroughly to the soil, until the first moisture content is attained. Again, account for hygroscopic moisture as necessary. We also need to measure the mass of the compaction mold and base plate to 1 gram. Do not include the extension collar in this weighing. Assemble the extension collar and compaction. The soil sample will be compacted in 3 equal layers. Each layers is compacted with 27 uniformly distributed blows before the next layer of soil is added. Smooth the surface of the soil with light tamping and then begin compact the soil with the 2.5 kilograms rammer. After the third layer has been compacted, remove the extension collar from the compaction mold. Using the steel straight edge, trim off the excess soil until the sample is even with the top of the mold. In the event that a small quantity of soil is lost from the compaction mold during removal of the collar or during the trimming process, fill the trimmings pressed in with moderate finger pressure. Measure the mass of the compaction mold, base plate, and compacted soil to 1 gram. Extrude the sample from the mold and get the sample from the soil for a moisture content determination. Break up the extruded sample by hand, and mix with excess soil from the previous compaction test. Add water, mixing thoroughly, until the water content of the soil has been raised by 2 to 3%. Repeat steps 4 through 10. Note the consistency of the soil and the total weight of the mold, collar, and moist soil throughout the 3 trials. We can stop this process when the mass of the sample is reduced in mass weight.
Once the water content samples have been dried, determine the water content and dry unit weight of the soil in each trial. All the data were recorded in the Proctor compaction table. Then, from the data the graph of dry density versus moisture content is plotted. From this graph, we can identify the optimum water content value for soil sample to get the maximum density of soil.